Test, retests, reliability. So here we go. First table, we have descriptive statistics. We have the 8-foot up and go. This is a physical performance measure that I'm currently using in my research study that we're doing now. I have about 100 research participants coming in over the next month, and I have about 40 research assistants who will be collecting data on all of these study participants. One of the measures that we have our participants partake in is called the 8-foot up and go. I have my participants sit down in a chair, and when I tell them go, they get up out of the chair, walk around a cone 8 feet away as fast as they can without running, and then sitting back down. And I time them. And we do it twice. 2 different times. So in this first table, descriptive statistics, we see for time point A, the average time it took 62 individuals was 4.95. We had them do it again. 8-foot up and go, time point B. These same 62 individuals, the second time around, their average was 5.97. I'm going to take a quick side note here. Notice that whenever we're pulling data from SPSS, round 2 decimal places to the right. So notice time point A, average is 4.95 with a standard deviation of 1.08. Time point B, average 5.97, standard deviation 1.37. So I just want to make a little side note there in terms of when we're pulling numbers from SPSS, what do we report? What do we use if we have to do CAN calculations or if we're writing the final answer? If you're pulling numbers from SPSS, 2 numbers at the end. But we want to really look down here at the second table. What do you notice here? Does this table look familiar? Hopefully it looks a little familiar. It's something that we saw in Chapter 5. This is a correlation matrix, and we have our 2 variables, time point A and time point B. As we can see, diagonal for time point A, 1 and 1, time point B, 1. And then on each side we see the Pearson's correlation coefficient for the relationship between time point A and time point B. And we see Pearson's correlation, little r, is equal to 0.769. So if we're just thinking about what we learned last week in terms of how do we interpret Pearson's correlation coefficient, we would say that the relationship between time point A and time point B was a strong, direct relationship. However, when we're talking about test, retest reliability, we really want to think about it a little bit differently. We want to look to see whether or not this test, the 8-foot up and go, is a reliable test in terms of test, retest reliability. If we were to administer this test different times throughout the year or throughout the day, will it measure 8-foot up and go, which is a measure of lower body agility, power, and strength? Will it measure lower body agility, power, and strength every single time? So when we think about looking at test, retest reliability, in order for us to determine what our coefficient is, our reliability coefficient, we either have to hand calculate Pearson's correlation coefficient, or we look it up in an SPSS output like we do here. But again, when we're looking at R, which here is 0.769, we are not interpreting our test-retest reliability to be strong, direct. We want to talk about it in terms of, is it reliable, yes or no? And we'll see in a little bit, how do we determine if a test is reliable, yes or no, based upon the type of reliability measure we're doing. So again, retest reliability, looking to see whether or not a specific measure, in this case the 8-foot up and go, is stable over time, different time points. We determine this by calculating or running an analysis of Pearson's correlation coefficient. And we use little r to determine whether or not this test is reliable, yes or no. We do not interpret little r, Pearson's correlation coefficient, as strength or direction in terms of determining reliability. Okay, parallel forms reliability, our second one. So when I did my master's thesis, one of my outcome measures was looking at neuropsychological performance. How well do people perform cognitively when they have fibromyalgia? And one of the ways that I measured cognitive performance was having them do a battery of physical tests, or cognitive tests, rather. And so one of those was called the Controlled Oral Word Association Test, also known as COAT. And in my study, I had them complete the COAT before they did the intervention. Then after 6 weeks of either education or drumming, I had them complete the COAT again. But I couldn't have them complete the exact same test because they will have seen it before, so I had to do something a little bit differently. So before the intervention, I had them complete the COAT. And the COAT essentially is, I give them 1 minute, and I say within 1 minute, I want you to say as many words as you can that start with the letter C. They give me all the words they can say in a minute that start with the letter C, and then I say, okay, now I want you to do the same for the letter F, and the same for letter L. And of these 3 letters, we count up how many valid words do they have, and that will make up the total COAT score. Well, think about this. If you were a participant, one of my participants, and I had you say, okay, name all the words that you can think of in a minute that start with the letter F. Ready, go. You'll say all those words. If I had you come back again 6 weeks later, and I asked you to do, okay, I want you to think of as many words as you can in a minute that start with the letter F. Go. Well, you've done this already 6 weeks ago, so you have already primed for that. You already have some idea of some of those words. So it's not really cheating, but it's a practice effect is what we call. So instead of giving you the exact same letters that you did 6 weeks ago, I had to give you 3 different letters. In this case, the post-tests, the post-COAT, utilize P, W, and S. And then, of those 3 letters, we had a total post-COAT score. Well, I wanted to see, okay, well, knowing that I used 3 different letters before the intervention, and 3 letters after the intervention, how do I really know that it's supposed to measure verbal fluency, which is what the COAT measures? Well, one of the things that I can do is see whether or not these parallel forms, these 2 different forms, are equivalent in measuring what it is we want to measure in terms of verbal fluency. Are they equivalent and are they reliable? Every single time we use it, it's going to measure verbal fluency, no matter which one we use. And so we can look at pretty much the total COAT score and the post-COAT score and see whether or not these 2 scores correlate. So we can see here total COAT score and post-COAT total score. We have Pearson's correlation coefficient equal to 0.901. So let's step back and think about this. How would we define or interpret the relationship between total COAT score and post-COAT total score? It would be what direction? Positive or direct, And what's the strength? Very strong, right? If you think about Pearson's correlation coefficient, they range from -1 to +1. Well, in this case, we have 0.901. That's really, really close to a perfect relationship. So yeah, look at that, 0.901. That's really close to 1. So we would say that, yes, these two are very strong, positively correlated. But again, what are we talking about in this chapter? We're talking about reliability. So we need to step back and say, okay, well, even though I know that the relationship between both total scores is very strong and direct, I'm looking at it in the terms of reliability. So this 0.901, while it is Pearson's correlation, little r, it is also our parallel forms reliability coefficient. And again, when we're thinking about reliability, we want to ask ourselves, are these two forms reliable? Are they equivalent? Yes or no? We are going to use Pearson's correlation coefficient, or reliability coefficient, to help us answer yes or no by comparing this 0.901 to our threshold.